Greetings to one and all. Now we are going to see about cache memory. I am Chitra, Assistant Professor, Department of Computer Science Cell, VVV College for Women, Virudhunagar. Cache memory is the fastest memory. We can use it for performing various tasks. What is the fundamental idea behind cache organization is the reference to memory by a program is confined to some localized memory. So, in cache organization, we prefer to keep the frequently accessed instructions in the cache memory. So, the execution speed and the access time reduced considerably. So, this is the size of cache memory when compared to main memory. The main memory capacity can store up to 32,000 words of each 12 bits. But the cache memory capacity is only 512 words with 12 bits. So, the most important instructions that are frequently accessed can move from main memory to the cache memory. So, the execution speed and the access time is increased much. So, to measure the performance of a cache memory, hit ratio is used. Hit means when a CPU refers to the memory and it finds the word it needs, means a hit occurs, and miss occurs if a CPU doesn't find the word in the cache. Then it have to move that word from main memory to the cache memory to proceed further. So, in the calculation of hit ratio, we have to divide the total CPU references, that is hit divided by hit plus miss, to calculate the hit ratio. To have the efficient cache memory, the hit ratio must be 0.9. Next, when to transfer the data from main memory to the cache memory, a mapping process have to be used. There are three types of memory mapping processes in cache memory. First one is associative mapping, second one direct mapping, and third one set associative mapping. First, associative mapping. To have a flexible and fastest cache organization, we can use associative memory. In associative memory, we can store both the address and content of the memory word, that is data. And the address value is stored as 15 bits. It's converted to 5-digit octal number, and the corresponding 12 bit is converted to 4-digit octal number. So, the CPU address of 15 bits is stored in argument register in associative memory, and that argument register we can search for the particular address. If the word is found, then the corresponding word is read from CPU with its corresponding 12-bit address. If the word is not found, the main memory is accessed to get the data from it. If the word is to be replaced, the replacement algorithm used here is first in, first out. So, this is a diagram for associative mapping in cache. In CPU, if the CPU address has 15 bits, that 15 bits address is stored in argument register. And in associative memory, address and data are stored. From this argument register, the 15-bit address is used to compare the address in the associative memory. If the address is found, the data is retrieved from the associative memory. If the address is not found, the data is moved from main memory to the cache memory. And the next mapping is direct memory. In associative memory, we are using associative memory means it is very expensive. So we are using random access memory. Here the address bit of CPU which is 15 bits is divided into two fields. The least significant 9 bits are used to store the index field and the remaining 6 bits are used to store the tag field. Then if a main memory needs an address, it has to include both the tag and the index bits. The tag field of the CPU is compared with the tag in the word read from the cache. That is, if that word is found, a hit occurs. If the word is not found, a miss occurs. So the word has to be moved from main memory to the cache memory. What is the disadvantage in this type of direct mapping is the hit ratio can drop considerably. The two or more words have the same index in the tag field. So to avoid this, a new memory organization is created. So this is the diagram for direct mapping. That is, here the physical address is converted to 6 bits tag and 9 bits index. And using that, here is the main memory and here is the comparing cache memory. So using the index, that is first 3 bits are index address. So using that address, we have to point to the corresponding tag in the cache memory. If the tag bits are found, then the corresponding data in the cache is accessed. The tag bit is not found, then the word has to be moved from main memory to the cache memory. To avoid the multiple words with the same tag field, we are now going to divide the index field into further two fields, that is block field and the word field. That is, in cache memory we can store up to 512 words. Each block can hold up to 64 blocks can hold up to 8 words each. Hence, the block number is specified with 6-bit field and the word is specified with only 3 bits. So, the tag field is stored in cache memory for all the 8 words in the corresponding block. If a word is missing, then from main memory we have to move the entire block into the cache memory. So here is the modified diagram for direct mapping with the tag field is index field is divided into block field and the word field. Here for block 0 we have index from 000-007, but the tag is common for all the 8 words and the corresponding data is found with the help of the index. So here we have 64 blocks and each block have the same tag field but the different index field. With the corresponding index we can find the data we need for execution. And the third type of mapping is called set associative mapping, which is an improved version of direct mapping organization. In this, for each word we are going to store the tag and its corresponding data. Here we can see for the index 00 we have two tags 01 and 02. So direct to the index we have 01 index 01 tag we have the corresponding data and for 02 we have the corresponding data. So each word is stored together with its tag and the number of tag data items in the cache. So here we form a set of tags for the same index. So it is feasible for searching with the same index but different tags. So what is the replacement algorithm here we used for set associative mapping means random replacement. In this random replacement we are going to replace the already available item in randomly. In first out we are going to select the item that is in the cache memory for longest time. In the least recently used, we are going to select the replacement item that has been least recently used by the CPU. So when this replacement algorithm is going to use means when a miss occurs, we have to move the data from main memory to the cache memory. If the cache memory is already full, we have to replace the already existing data. And next we are going to see about writing in cache. So to write a data in the cache memory, we have two methods. One is write through and the second one is write back. In write through, we are going to update both the cache memory and the main memory, in parallel. That is, the content of the cache memory and the main memory are common at the time of accessing. Second one, write back means only the cache location is updated and it is marked with some special flag which is removed after the value is copied from cache memory to the main memory. So this is useful because the update in cache memory is done after the completion of execution. Only the final value is going to be updated in main memory. At that time, only the value in cache memory is accessed by all, not the main memory. So there is no clash, that is a value in cache memory and the main memory are not same, but we have the updated value only in cache memory. At the final execution only, we are moving the original value from cache memory to the main memory. After that, the other programs can use the value of the data item. And next one is cache initialization. So the cache is initialized when we apply a power to the computer or when we are loading a program from main memory to the cache memory. After the initialization, the cache is considered to be an empty one and it may contain some non-valid data. So each word contains a valid bit which indicates that whether the word is valid or not. If the valid bit is 0, then the word is not valid, that is the cache is in a initialized mode. Initialized means we are just clearing all the values. If the valid bit is set to 1, after we are loading the data items and the programs from main memory to the cache memory. Using this valid bit only, we can further use the data item from the cache memory. Thank you.